Tap, tap plastics.
There are times when you would like to duplicate a part in fiberglass, like this hull. This video segment will show you how to make a fiberglass mold. In part 2, we will show you how to do a fiberglass layup in the mold, creating your duplicate part. This video will be brief. You can find complete instructions in various books offered by Tap Plastics, both on the web at tapplastics.com and in our stores. The first step in making a mold is to mount the original part to a solid, non-porous surface. We are using a piece of coated hardboard. The mounting method will depend on your piece. In this case, we have glued a piece of plywood to the hull and will then glue that part down with a glue gun. A glue gun is ideal because it is fast and the glue can easily be later removed. After mounting the part, also called the plug, to a base, check to make sure there are no gaps between the plug and the base. Gel coat cannot span gaps, so they must be filled. We will use clay. It can be pressed into the gap and then trimmed with a knife to produce a clean corner. Examine your part carefully. Any imperfections in the plug will be duplicated in the mold and then in every part that comes out of the mold. Now we're ready for mold release. Mold release is essential in order to remove the cured mold from the plug. This is a two-part process. First, apply Tap Green Mold Release Wax or Part-All Paste 2. Apply the wax and buff it off. If your part is porous, it must be first sealed. Be sure to apply the mold release to the base as well. Once waxed and polished to a shine, apply PVA mold release. For a small project like this, a Preval sprayer works well. All these products are available at Tap Plastics stores and at tapplastics.com. The first coat of PVA is a very light mist coat. Allow it to dry, then follow up with 2 heavier coats, allowing each to dry before applying the next. Make sure the film is completely dry before proceeding to the next step. Now we are ready for the gel coat. Tooling gel coat is normally used for fiberglass molds. However, since we are not going to make dozens of parts out of this mold, the higher performance and cost of tooling gel coat is not necessary. We will use regular gel coat and add black pigment so that the gel coat will contrast with the white plug and with our final layup. It will help us to see thin or missed spots. Add catalyst according to the directions. The best way to apply gel coat is with a cup gun designed for spraying resins. Do not use a paint sprayer. The beauty of a cup gun is there is only one part to clean and nothing to take apart like there is with a paint sprayer. You can find cup guns for sale at tapplastics.com. Once the gel coat is loaded, be careful not to tip the gun forward until you are ready to start spraying. Otherwise, the gel coat will start dripping out. Note that this process should be done outdoors or with proper breathing protection. Spray in long strokes in one direction, then in the other direction for even coverage. The goal is to create a layer 18 to 20 thousandths of an inch thick, also known as 18 to 20 mils. The way to tell thickness is with a mil gauge. Roll it in the gel coat, and the number of ridges that are coated will tell you the resin thickness. Here you can see that the resin is on the 10 mil ridge, but not on the 15 mil ridge. That tells you that the gel coat is between 10 and 15 mils thick. We want it to be 15 to 20 mils thick, so let's add a bit more gel coat and remeasure. This time you can see the resin on the 15 mil ridge, but not on the 20 mil ridge, indicating that we are at perfect thickness of between 15 and 20 mils. Now that the gel coat is applied, we need to let it cure. That should take anywhere from 30 minutes to a few hours depending on the temperature, thickness, and catalyst ratio. We're almost ready to start applying fiberglass, but first we must deal with this sharp right angle. Fiberglass does not like to bend at sharp angles like this. There is too great a risk of creating an air pocket behind the gel coat, which would cause the gel coat to crack either when removing the mold or during layup. The solution is to create a cove or gentle curve to support the fiberglass fabric. We will create a putty by combining Cabosil and our resin. When Cabosil is added to a liquid resin, it can turn it into a peanut butter consistency for coving, filling holes, etc. For this project we will be using Tap Bond Coat resin because it is the most economical. It is a polyester, allowing us to control the rate of cure with the catalyst. Because of its odor, use it outdoors or with proper breathing protection. Spread the mixture of Cabosil and resin onto the 90-degree angle and use a finger or stir stick or other curved object to create a smooth coved surface. Once that is done, we are ready to begin applying fiberglass. Mix the amount of resin and catalyst that you can use within 20 minutes. Start by creating a clean, strong border with selvage tape. Wet the surface with the resin, and then apply the fabric, and then further wet and saturate it. We will build our mold using fiberglass mat. This is 3/4 ounce mat, though heavier could be used. Wet out the surface and apply the first layer of mat. Use a dabbing motion with a brush to saturate the mat. When it is saturated, it will easily conform to curves. Cutting the mat into small pieces makes it easier to apply. Be careful to overlap them so that there will be no seams. Use straight edges around the edge of the mold. Using a mat roller greatly helps lay the mat down and remove bubbles. Apply several layers to give the mold the necessary rigidity. 3 to 6 layers will be adequate for this mold. Some molds may require 6 to 10 layers or even more depending on their size and shape. Note that the mat, selvage tape, and many more fiberglass fabrics are available in the Tap Plastics stores and at tapplastics.com. For the final layer, to create a tack-free surface, we add surface curing agent to the resin and apply a top coat to the mold. Allow the whole mold to cure overnight. Removing the mold can sometimes be a challenge. Start by breaking the seal around the edge with a putty knife or a plastic wedge. Then work your way around and loosen the whole thing. If the boat comes off the board, carefully loosen it in the mold without scratching the mold, and eventually it will pop out. Because we had good thorough coverage with the PVA, the boat is coming out quite easily. The green film you see me pulling off is the dried layer of PVA which acted as a barrier between our mold and the original boat. Any PVA that does not peel off can be easily washed off with water since it is water soluble. We now have a mold ready to prepare for the layup to build a new hull. See part 2 of our video series, How to Make a Fiberglass Part, to see us lay up the new boat hull in this mold.
Tap Plastics, the fantastic